Hello, hello. Morning. How's the conference going? Did you enjoy last night's party? Yeah. I'll repeat it again. So if you enjoy the party, blink your eyes, please. My name is Álvaro Sánchez, and I'm promising you two things. You will learn something new, and you will have fun. So let's begin. As I was telling you, my name is Álvaro Sánchez. I'm coming from Madrid. I'm a Java developer, currently working on Micronaut. I'm working for Oracle Labs, which is the part of Oracle that it's bringing to you not only Micronaut, but also GraalVM, or the Graal project itself. I'm not a developer advocate myself, just a committer on the project, but I enjoy going to conferences and talk about these type of things. I have been working on Micronaut since the beginning. We started this project in 2017. The team working on Micronaut is basically the team that created Grails. And we wanted to start from scratch and create something new. And I'll tell you one story, which is funny, but true at the same time. So originally, this project wasn't named Micronaut. The name was different. The original code name was Particle. But apparently, Particle, we couldn't use that name because the main name was not available, blah, 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 whatever. So we had to choose a new name. So that we ran a poll internally in the team to choose a new name, and I proposed one name, which wasn't selected. I don't understand why. So my proposal was to name the framework Summer, because summer is better than spring, and this is a joke. Jokes aside. Yeah, I actually did work for VMware. It's a fantastic company. I have nothing to say against them. Yeah, so that's enough about me. So now about you. How many of you are using Spring? Okay, you can leave the room. Thank you. Now, you're here in the right place because you're using Spring, but you're guessing that there's something else out there. Right, so Spring has been with us since year 2000, 2001, and there's probably something else, and I'm going to tell you about that something else, and then you will decide what you want to choose. All the slides are available on speaker deck. So let's talk about Micronaut. Who heard about Micronaut before? Who's using Micronaut? Okay, I'll raise my hand. Okay, there's three ideas I would like you to get out of this presentation. One is that Micronaut is a modern open source Java framework. And by modern, I mean that we started creating this framework in 2017, thinking of the type of applications that are created nowadays, like microservices, serverless functions, and thinking in the cloud. So any of that didn't exist in year 2000 when other frameworks were created. So we had the advantage of thinking about the type of applications that are created nowadays. Like, imagine there's no application servers anymore, or, well, they're still there, but not very used. So now the applications you guys create are different. And we wanted to support that model since the beginning. It's a general purpose framework. People typically use it to create REST APIs, but you can create, like, for example, a Kafka consumer or a producer that has no HTTP server whatsoever. So it's like headless to say. You can create a serverless function and deploy it on AWS Lambda, a CLI application, you name it. And it is highly optimized. So for us, performance is very important. And for us, performance means two things, startup time and memory consumption. So we work hard constantly to shave every millisecond from the startup time and to shave every megabyte from the memory consumption of your applications. And this has an impact on your developer experience. I will show that later. How do we do that? We do that using a technique which is called AOT, ahead-of-time compilation. So traditional Java frameworks are normally runtime-based. So they have, you have annotations all over the place. Micronaut is using as well an annotation programming model, so it's using annotations. And traditional frameworks, what they will do is basically at runtime, they will scan those annotations, and then using reflection, Java Reflection API, will read them, will process them, and then will dynamically generate bytecode on the fly, or they will generate proxies, and etc. And all that will happen at runtime. And the more beans you have, the longer it takes for your application to start up, right? It's linear, right? Relationship. At Micronaut, we are choosing a different path. So what we do is annotation processing at compile time. We're using a Java facility that was almost always there, but very few used it for this purpose, which is the ability to hook into the compiler and process the annotations at compile time. So we are able, like for example, when you have a at singleton annotation, we are able to produce the Vim definitions and the internal framework infrastructure at compile time, so that at runtime, we only have to execute it. So therefore, startup time is much faster, way much faster. Generally speaking, what we do is we process your source code during compilation, and for most of the cases, we generate bytecode. There are some cases where we are going to start. We are starting recently to generate source code. It's both approaches have pros and cons. So generating bytecode, we save one compilation round. So what we process during compilation is already compiled. It doesn't have to be compiled again, so it's faster. But also users like to have the source, all the things that we generate. So for that reason, we are enabling to generate source code for other use cases. So at runtime, we don't use reflection. The problem with reflection is that the reflection is slow. It's getting faster with each Java release, but it's a slow API. Because it is slow, what happens when you use like a traditional framework or other things like, for example, Hibernate, each of those frameworks or libraries will have their own reflective cache. So you're not querying over and over again for, tell me which are the members of this class or which are the annotations of this class. They have a cache, and that cache goes to the memory. The reflection usage is slow. Those caches will consume memory. We don't do any of that. We don't generate proxies at runtime. No CGLib, anything. We don't scan your class path, nothing. So startup time is faster. It's a general purpose framework. You can use it. The three languages supported are Java, Kotlin, and Groovy. So for Java, we use the annotation processing API of Java. For Kotlin, we can use KAPT, which is the annotation processing support of Kotlin, or even KSP, which is the new model, Kotlin Simple Processing. And for Groovy, we use AST transforms. And the three things will happen at compile time, depending on the language. We have built tooling for Maven and Gradle, and you can use any cloud, etc. So this is the typical hello world. So like I said before, we use an annotation programming model to get you familiar with. And actually, we purposely have chosen to not bring like new names. Like, for example, we have an application context, we have beans, we have property sources. We have a lot of terminology that is already familiar to you, because the idea is that for those coming from other frameworks, they should feel like at home. And that's the idea. So if you're coming from Spring or from something else, you should feel like at home. In this case, well, the pointer is not working. In this case, the annotations are Micronaut annotations. But there is something interesting with the annotations, and that we have the ability to let you choose, for example, for the controllers, the REST controllers, you can choose Spring MVC annotations or JAX-RS, right? We don't care. How is this working? The way this works is that we are able to map from those annotations to the internal Micronaut ones at compile time. So your source can be compiled with Spring MVC annotations, but at runtime, there's no Spring MVC at all. It's only Micronaut. And this happens also for example, JPA. You can use JPA annotations, but not use Hibernate at all. So that works. And it's great because this will help you migrate from existing application to a Micronaut application. We not only support like Spring MVC annotations, we support also some of the Spring Cloud, Spring Security, and Spring Data annotations. So this is a great technique to do migration. We have other things built in, like for example, an HTTP client, a declarative HTTP client, who's used Spring Cloud OpenFame. Nobody? Yeah? Two people, yeah. This is the same approach. So you have a class or an interface in this case, and then you use annotations, and then in the case of Micronaut, the HTTP client is going to be implemented at compile time, right? And this client can use service discovery, blah, 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 so it's all wired. For messaging, we support the major technologies. For data access, we have a solution called Micronaut Data, which is based on the repository pattern. You have seen this pattern before. But again, the difference is that everything is implemented at compile time. And there is a nice feature or a nice consequence of being in compile time framework. So in this case, you have a method called find by name or order by name. So there is like a convention for Micronaut to determine which is the query that needs to run based on the entity. In this case, we have a user entity. So imagine that the user entity has a name property. If you were to make a typo in, for example, the name parameter of the method, it will not compile. You will get a compilation error. Not a runtime error when you actually execute it, but a compilation error. That's very nice, in my opinion. So you get faster feedback for your problems. And with Micronaut Data, you can go down to the SQL level if you want. So there is like a craft repository offering the common queries, but you can customize it to your needs. For security, we support like the major technologies, JWT, OpenID Connect, OAuth 2, etc. I wouldn't extend too much. We have very nice integration with test containers. So who's using test containers? Yeah, quite a few people. Who doesn't know what test containers is? Okay, almost everybody knows what it is. So with test containers, so test container has a Java API to run containers for your tests. It's, the name is quite obvious, no? It's test containers. Now we've gone with integration a bit further. And what we do is we allow you to use test containers without using the test containers API whatsoever. I will show that later, but essentially the idea is that you have an integration test or a functional test for this matter. Imagine there is a test where you want to inject a repository or a service and then make a method call, and that should have, database, whatever. So before the tests are going to be run, we will spin up a container for your tests. And then this container will be teared down once the tests are finished. We do that automatically without you specifying any configuration whatsoever. So what we do is essentially look at your dependencies, and we look at your configuration. So if you have, for example, the Postgres driver on the class path, and you have not specified the Postgres data source configuration, like the URL, username, and password, then it's a hint for us to say, OK, this guy needs a container, and we will run it for you, right? But the magic of that is that it not only works for tests, but also for local development, right? So you get the same behavior if you run your application in development mode. I will show that later. And we have many more things. I will go a bit quick about this, but for dependency injection, which is the core of the framework, again, you can use Spring annotations as well. So you can use a component at AutoWire. It will work. For configuration, we have the typical support that you have, so multiple formats supported, configuration classes, configuration validation, type-safe configuration, etc. For validation, we have a built-in validation engine, which is way faster and smaller than Vim validation API, than Hibernate Validator, right? However, if you need to use all the Vim validation API, then you can just plug Hibernate Validator in your class path, and it will work. But if you don't need the whole API, then you can use the built-in Micronaut validation framework. It's going to be faster because we don't use reflection. We have an AOP framework internally, but this compile time and reflection free. And many more things, like distributed tracing, service discovery, distributed configuration, monitoring, Kubernetes support, cache abstraction. The cache annotations, you can use Spring annotations or Micronaut annotations, so etc. You can get started with Micronaut Launch, which is a website similar to Start Spring.io. This is Launch Micronaut.io. And then usually the features that you want, and we will generate a skeleton application for you. Or you can download our CLI if you're a terminal person. The options are going to be the same. There is an IntelliJ IDEA wizard with the same options, and a Visual Studio Code extension pack, again, with the same options. So we've got you covered wherever you are. Few notes about Micronaut 4. Although we're already working on Micronaut 5, but the idea is that we release a new major version every 1.5 years. Ideally 1 year, but sometimes we are late. So the current major version is Micronaut 4, which bumped the minimal Java version to Java 17. So who's using a version before 17, like less than 17? Who's not on 17 yet? Only 3 people. I feel your pain. Please update, because you will see a lot of benefits. So for us, we moved from Micronaut 3, which was a Java 8 baseline, to Java 17, multiple improvements. Both for us as a framework developers, so we're able to use the new language features in the code base, and also for you, because you're able to use, for example, virtual threads from Project Loom, or a new HTTP client implementation based on the built-in HTTP client from the JDK. But the good news is that if you're not on 17 yet, you can use Micronaut 3. It's going to be supported for many years. So you can use it, but please upgrade. In terms of performance, there is, like I told you at the beginning, so performance for us is very important. Let me tell you something. So there are 4 major Java frameworks for creating applications. You have Spring, you have Micronaut, you have Quarkus, and you have Helidon. Okay. The 4 of them are based on Netty. Netty is essentially a low-level I/O library. It's very low-level, right? So basically, nobody's using Netty directly, right? So basically, you have frameworks on top of Netty to be able to create controllers and things like that, to have dependency injection. You have, like for example, Vertex. Vertex is the closest user to Netty, so you can define handlers. But still, it's on top of Netty. So we've achieved almost raw Netty performance, which is amazing. So the things that Micronaut is putting on top of Netty are basically not going to affect performance. So we have Hello World application is 200-ish milliseconds to start up. We actually have one of the Micronaut committers is also a Netty committer. So we're able to improve Netty as well for certain things. So we're in close collaboration. We introduced recently a compile time expression language. So if you have used Spring Spell, this is a similar idea. But again, this is going to be checked. It's going to be type checked at compile time. So it's much safer at runtime. And again, see that JC variable. So if you make a typo in the expression, it will not compile. We are also introducing via the source generation some features like, for example, beam mappers. The idea is to eliminate the need for using additional libraries, like, for example, map extract. So obviously, we don't support all the use cases of map extract. But for the typical cases of converting from entity to DTO and vice versa, this is a built-in solution, and it's going to be faster. We've also introduced in Micronaut 4 control panel, which is a UI for development that can tell you it can tell you like, for example, which property sources you have in the configuration, and which properties and where are they coming from. You can see which pins are loaded and their dependencies. You can change the login during runtime. This is for development, basically. And there is a source generation module coming soon. And we're adding like some annotations, like, for example, at Builder. Again, we're targeting Lombok here. So who's using Lombok? You can also leave the room, please, because Lombok is absolutely evil. I understand why users like Lombok, but the things it does to your bytecode is absolutely crazy. So please don't use it. We're like adding few annotations here, like, for example, at Builder or at Wither, to help you to reduce your need to use Lombok. You can use Lombok with Micronaut, by the way, but what happens is that Lombok has to be the first annotation processor because it manipulates the AST, which is really crazy. So if you, for some reason, happen to have the Lombok processor after Micronaut, it will break everything. So don't use it if you can. Some other things, like, for example, the ability to generate a JSON schema from your sources. We already support generating open APIs or Swagger specs, everything at compile time, but the JSON schema is something new. So that's basically it. Now, there's something I will mention very quickly. So Micronaut is an open source framework, has Apache 2 license, and it's governed by the Micronaut Foundation, which is a non-profit. Well, anyone can contribute, and it's an open source project. Now, Oracle is building a downstream distribution of Micronaut, which is called GDK, or Graal Development Kit. So the Graal brand, I will talk about GraalVM later, but the Graal brand is becoming an umbrella brand. And it's going to be the home of 3 projects. One is GraalVM, which you probably already know. The other one is this one, is GDK. And the third one is GraalOS, which will be a serverless platform built on top of Micronaut and GraalVM. So basically, GDK is a downstream Micronaut distribution built from source by Oracle that offers, enterprise customers, those people that are not able to fetch dependencies from Maven Central. They give you like provenance and security scanning, vulnerability scanning, blah, blah, blah. So if that's your use case, this might be useful. But I do recommend to check graal.cloud to see those 3 projects that I'm talking about. And now some notes about GraalVM. So who's using GraalVM? Exploring, still exploring? OK. Who knows what GraalVM is? Yeah, OK. So what is GraalVM? GraalVM became famous for one particular thing, very, very small part, which is native image. But let me tell you something. GraalVM is an OpenJDK distribution, right? You can use it as your local JDK, as your production JDK. It has a Java, Java-C, Java-Doc, everything inside. And it's going to be faster. Like if you change from Eclipse to Murin or whatever you're using for GraalVM, your applications will run faster, like that. And there's been, I don't know if you've been aware of the 1 billion row challenge on the internet. So basically, if you look at the top, I don't know, top 5 or something like that, I think the top 4 were using GraalVM native images, but the others were using GraalVM JIT, and simply switching the JDK. So you could take any solution and change the JDK from Eclipse to Murin to GraalVM, and it was like 10% faster. So it's crazy. So basically, GraalVM is an OpenJDK distribution that allows you to use 2 paths. On the left, you have the JIT mode, which is what you normally use, right? So you compile your classes to bytecode, and you run them, blah, blah, blah. But it allows you to use a different approach, which is AOT. So it has a native image component, which, by the way, is in the process of being merged into OpenJDK. So in the future, all the OpenJDK distributions will have native images. It allows you to turn your Java application into native executable. What they do essentially is basically traverse your application from the main method and will compile to machine code all your application. And then you have a native executable, which will start dramatically fast and will consume less memory. So startup time is important. So we're talking about, if I tell you, like, for example, a hello world in Micronaut is 200 milliseconds. In JIT, in native image, could be 6, 7, right? 7 milliseconds. Low resource usage, so it consumes less memory and less CPU. So you can increase your server density, like, for example, having more pods per node if you're in Kubernetes, or whatever, or more instances if you're deploying a server. Minimizes vulnerabilities because in the process of traversing your source code for generating the native image, it will drop unused code. And this is really important because how many of you is using common slang? Everyone should raise the hand, because I'm pretty sure everyone has common slang in the class path, even if you don't use it. But there's some people like having common slang dependency for that particular string utils method that they are using. And in exchange, you're getting not only common slang jar, but all their dependencies, which could be vulnerable, and etc. So if you're using like a single method from a single class, GraalVM will drop everything else, right, from the native image, which is great. So the surface attack is smaller. And compact packaging, you have a single binary, which you can distribute and has everything inside. It can be dynamically linked. So you install on a machine that has libc or muscle, and it will run. But you can even generate a static native image with all the compiler libraries inside. So you can have a scratch Docker image and then your native image, and that's all. Now, all the 4 frameworks that I mentioned before, they all support GraalVM. But the combination of Micronaut and GraalVM is unique. You will get the fastest and less consuming applications, not only without a performance penalty, but with a performance benefit, right? So this 1 billion row challenge, I told you, the top 4 or top 3, something like that, were using native images. So Micronaut and GraalVM are sibling things inside Oracle Labs. We are ready for GraalVM since day one. We were the first framework to support GraalVM. Why? Because we don't use reflection. We don't use proxy generation. We don't use any of that. Can you use reflection with GraalVM? Yes, you can. But you need to tell GraalVM about it, which is called a GraalVM metadata, right? So all the frameworks have to spend 3 years, basically, producing metadata for GraalVM to be able to produce native images of their sources. We didn't have to do that. And the Oracle Labs team, we have like a tooling team which is producing Visual Studio Code and IntelliJ IDEA plugins for Micronaut and GraalVM. Now I want to appreciate the collaboration with the Spring team, because there is something called GraalVM Reachability Metadata Repository. So what happened was that, for example, we don't have any metadata, GraalVM metadata for Micronaut sources, but we had metadata for third-party libraries so that they could work. And then Spring had their own, Quarkus had their own, although Quarkus doesn't use much metadata. But basically, at one point, we decided to join forces and to collaborate together. And now we maintain a single repository with metadata for all the libraries that people use in their applications, like Netty, Hibernate, etc. So it's a growing collection. And it's essentially what you get if you're using Spring or Micronaut build plugins. It's the same thing, right? And now a few notes about performance. So this is a performance comparison that used to be run by Matt Rabel, he used to be a developer advocate at Okta. And he was running periodically framework comparison. He was using, it wasn't an empty application. It was, so it had a few things inside, like authentication with Okta. So it wasn't super complex, but wasn't empty either. Basically, Micronaut has been consistently the fastest to start up, the fastest to start up in native mode, and the one to use less memory, right? So unfortunately, he's no longer doing this, but it's just an idea of how important it is for us, the performance. And then a final note of a popular use case. So Disney Plus is using Micronaut and GraalVM in AWS Lambda. Is anyone running Lambda in production? Yeah, only two, yeah. So I think startup time matters for two things, in my opinion. One is developer experience. I will prove that in a moment. The other thing is that there are two use cases to me that I think this is important. One is, like for example, serverless. Obviously, serverless. The less time your function takes, the less money you pay. It's literally money, and they made the numbers. So they could have used like Micronaut on Git mode, and they would have saved a bit of money. But going GraalVM Native Image, it's even more than that, right? So you want functions that run fast. The second use case is, for example, Kubernetes, who's running Kubernetes in production. Yeah, I feel your pain as well. So for Kubernetes, I think it's interesting to have pods that come up instantly, because in that case, you can think about, for example, scaling to zero, right? It's an ability that you probably didn't have before. And it will, like I mentioned before, you can increase your density. So you can have more pods per node and increase your high availability. OK, so let's show some code. Can we switch off the lights? What I have here is a simple Micronaut application. So with Micronaut, we have a main class. If you forget about this for a moment, it's basically this main method. So this is typical. Is it too dark? It's OK? OK. I can make it light if you want. So this is the main class. Then what I have here is an entity. In this case, I'm using JPA annotations, but I'm not using JPA. I'm using, so Micronaut data comes in two flavors. One is Micronaut data JDBC, which is a lightweight version where there's no, for example, there's no Hibernate whatsoever. We generate JDBC queries at compile time, and but obviously you don't have like all the features of Hibernate. There's no DDL generation or anything like that. So depending on your needs, this is probably enough. or if you need like Hibernate, then you can use Micronaut Data JPA. But then in this case, I want to use JPA annotations with Micronaut Data JDBC, because like I told you, we have the ability to map from these annotations to the Micronaut data ones at compile time. This is the repository. It's empty because I'm happy with the default operations. Then, apart from the entity, well, this is about football teams. So has like two properties, name, stadium, and I have a DTO which combines those two fields into a single description, just for the sake of using a mapper. So this is an interface that is going to be generated at compile time, and what I'm doing is essentially, from the entity to the DTO, we combine the two fields in a single field description, and then we unroll them when converting from the DTO to the entity. Now for the REST API, what I'm doing here is I have an interface here. And I have an interface with the operations and the HTTP annotations. So this REST API has three operations: list, find by ID, and save, right? And there's two implementations of this interface. One is the actual controller. The controller is using, should have used a service for this instead of using the repository and the mapper directly. But I thought it would complicate more the sample. So this is simply implementing the operations, right? Nothing fancy. For the REST API, you can return POJOs or collections of POJOs, or you can wrap them in HTTP responses. You can return reactive types. You can basically return anything, and we will figure out what to do with it. And what else? That's basically it. So let me, for example, before doing this, if you look at the configuration, so I have here like a DDL and inserting some data. And this is my configuration. So I have the driver on my class path, the Postgres driver. But this is all my configuration. There's nothing else. So like I told you, if I run this in development, and if the demo gods are with me, we have somewhere over here like a Postgres container being created, right? So I think this is great. We have development. I have a class that will insert the data, and they should be working, so we can supposedly make a request and get all the teams, okay? Now, let's look at the test. So what I'm going to do is I will run MVN test for a moment. Right, so it's 5 seconds, including container creation and destroy. Again, for the test, we also have the test container being created automatically. So here we have the Postgres. So it works magically. Now let's look at the test itself. Because when you're developing the test, so this is how the test looks like. We have a Micronaut test annotation that will essentially start the application on a random port, and will make this class part of the application context, so you can inject any bin and then make calls for it. This is really interesting because you probably are suffering from from the so-called pyramid of testing, where you're supposedly to have a lot of unit tests, less integration tests, and very few functional tests. And this is an idea biased on the fact that is very slow to run functional tests. But if I were to tell you that the functional tests are fast, maybe you would think twice before mocking here that. I mean, you can still write unit tests with Micronaut, that's fine. But it's very pleasant to write functional tests. And in this case, I'm testing the controller. So I could grab the low-level HTTP client and then send JSON string to the controller and then assert on the response, pass the JSON back. But what if I could use a declarative HTTP client? So that's what I'm doing here. So remember this Team API interface, right? So I have a testing client for free with one line. This is great, and it works. I don't see your faces. You're probably like screaming in excitement. Yeah, so basically my test is really easy because I get the DTOs back, and I can work with objects and not with JSON strings. So how do you work with a test during development? In this case, you basically start the test resources service on the background, and then. Like, for example, this test, we can run it. Let me do it again because it was 161 milliseconds. So if you blink, you miss it. And I'm not kidding because blinking takes 300 milliseconds, so you're likely going to miss it. So it's 160 milliseconds for starting the application, running the SQLs, creating the connection pool, then running your test, and then tearing down everything. Well, actually, the container is still alive, by the way. So we keep the container running. But I think this is really interesting. And if we run all the tests, it's actually like the first one is like paying the startup time, but then the rest of them are really fast. Do you like this? I'm sure you do. And then the final trick of the show is going to be the native image. So I have, let me stop this thing. I have already generated the native image of this application. It takes 1 minute, but I only have 2 left, so I wouldn't waste 2 minutes. So what I'm going to do is, in this case, I'm going to be starting the database container myself, and of course I did a clean. Did I do a clean? Yes. Let's generate the native image. In case you were thinking like this guy is cheating me about the test, it's not possible that you're running like a full and having login for the queries. So we're running real queries against the Postgres database. This is the JSON response. The server is running on a random port, so is everything working? I'm going to steal a couple of minutes of your extra time for this session. I hope you can forgive me. Yes, I will show them. So we can start this. Let me do it again because it was too fast. 43 milliseconds. Okay. I have a feedback form, which I will really appreciate if you can let me know if you liked this session or not. And let me open the questions. There are quite a few. By using Spring MVC annotations in Micronaut, do you mean that imports also match Spring or only other annotation names? No, it's literally the Spring annotations with their imports. So you can have the Spring annotations on the compiled class path, or you can have them as provided. It's provided if it's Maven or compile only if it's Gradle, and it will work. With Spring, there is a curious case. So we were able to make the first Spring application to be compiled with GraalVM in the history, because with this technique, we have a library called Micronaut for Spring, which makes everything available. Micronaut for Spring has a Spring application context that can be the parent of your application context and is able to resolve Micronaut beans as well. So you can take a Spring application and use, for example, the Micronaut HTTP client, things like that. So yeah, it's basically Spring annotations, literally. Can you use custom HTTP client implementation with @client annotation? I don't know by custom, what custom means in this context. So @client is basically a declarative client, and then there is a programmatic client available. So if you are using a REST template, we have something similar, which is HTTP client class, if you want to do it programmatically. I already answered this one. When Micronaut source generation will be available? It's going to be available very soon, so there is a milestone already. And it will debut in Micronaut 4.5, which is due, it's either this month or the next month. If GraalVM is compiled to machine code, will it run on any machine, or do you mean JVM bytecode? No, it will run on, so what I generated is basically a Mac ARM application, right? It's only going to work on a Mac with ARM CPU, right? So it's dependent on the operating system. Can we disable test container provisioning test? Yes, you can. Is GraalVM Native Image FIPS 102 compliance? I have no idea, but there is a GraalVM Enterprise edition. I think it is. It must be because Micronaut and GraalVM are used across internally across Oracle. And Oracle Cloud has those FIPS requirements, so it should be. But you can, whoever made this question can reach out to me on Twitter, and I can grab the answer. Do you support transactionality out of the box? Yes, there is a transactional. You can use a Spring annotation as well in this case, but there is a Micronaut one, so transactionality, there is an annotation and a programmatic way. Do you have a revolver mode, a dev mode where a change in the source code can rerun all the tests? Yes, we have development time reloading, but it's not hot reloading, it's hot restart. Because hot reloading in an application is a can of worms because of class loaders and whatnot. So we didn't want to do that. So during development, when you use mn run or Gradle run, when you make a change to the source code, we restart your application. It's so fast that you really don't notice. But I don't recommend people running in development to test your application. I recommend you to write functional tests, same as I did. Is the sample code available somewhere? Yes, it's on my GitHub. So it's GitHub / Álvaro Sánchez, everything all together. Spring batch analogy in Micronaut, not to my knowledge, definitely not from us. Real Atletico, Real Madrid, of course, and I'm sorry about Lewandowski fans. It's been a terrible season for Barca, but it is what it is. Two final questions. Did you have fun? Did you learn something new? Thank you very much. You've been a fantastic audience.